This tutorial is to show how to run independent samples t-test. This is data set, so we're going to look at how music influences students' test performance. I have two groups, a control group and a music group. Both groups will complete a test. The difference is that the music group will listen to background music while completing the test. So we get the test scores from each group, and then we get the means and standard deviations for each group. So we can see that there's a difference in the average performances. So we want to see that if the difference we see is due to random sampling error or not by running a test. So we'll go through the hypothesis testing steps. So we're going to state the null and alternative hypothesis. The hypothesis is always stated about population values. So for the independent samples t-test, we would assume that the two populations have the same spread, and that means the same variance. So for our study, the null is the control and the music population, their means the same. So they have the same average performance in the population. Or the difference between the two population means equals 0. So these are the notation for. And the alternative will be the two means are not equal. And so to in a graphic form, so the null is that the two distributions, the test distribution for the control group, the test distribution for the music group, they overlap. The alternative is the two distributions, they do not overlap. That means the means are not the same. The significance level is 0.05 or 5%. That's our criteria to reject null. So if there's only 5% if the 5% or lower, that the difference we see in our sample is due to chance, we're going to reject null. The test, as we mentioned, is a independent samples t-test because the two groups are independent. And so next we're going to find the critical region. To find the critical region, we're going to find the critical value first. To find the t-critical value, we will need the degree freedom because we have two groups. Each group has have one population value to estimate. So that's n minus 1 for each group. And the degree freedom is 22. So once we have the degree freedom, we're going to use the t-table to find the t-critical value. So we're looking at the two-tailed test because there's no difference between the two means. And the alpha level, significance level is 0.05. And then we go down on this column to the degree freedom of 22. So we see that the t-critical value is 2.04. So that's our threshold to reject null by looking at the t-value. So it will be plus and minus 2.074. That's the critical value. So we're going to calculate a t-test statistic from our sample, that is the t-observed value. We're going to compare the t-observed value with the t-critical value. So if the t-observed value we calculate from our sample falls into the shaded region, so we have evidence to reject null. If the t-observed value that falls into the unshaded region, then the difference we see in our sample that's just no larger than the chance factor m. So to calculate the t-observed value, we're going to use this formula. So this formula has two components, the numerator and the denominator. The numerator is the difference between the two means. The denominator is the standard error. So we're going to compare the mean difference against the standard error to see how large the difference is. So we'll calculate the observed value. So first we're going to get the mean difference, the numerator part, the mean difference. So the difference between two means is we use the music mean minus the control mean. So it's a 7-point difference. And next, we're going to calculate the standard error. To calculate standard error, we're going to use the variance for each group. And so the variance is basically just standard deviation squared. And then we're going to divide the variance by the sample size to get the average variance. Then we pull them together and then take a square root. So, so first we're going to find the variance for each group. So that's a standard deviation squared. And then, so going to copy over for the other group. And next, so find the difference, divided the variance by the sample size to get the average variance. And then we're going to pull these two together. And then going to take the square root. So that's the what we get here is the standard error. And so for our data, this is sample size and standard deviation we have. So that's a standard error. So next we're going to compare the mean difference against the standard error. So how many standard error difference? So a 7-point difference for our data translated into the standard error is 1.68. So that's the standard error difference, which is not larger than 2.074. And so so which falls into the unshaded region. So our decision is because the 1.68 is less than 2.074, so we fail to reject. And conclude that music does not have an effect on test performance. So this hypothesis testing approach we went through is we calculate the t observed value, compare that with critical value. So this we call a critical value approach. And we can also determine statistical significance by calculating observed value, p-value, associated with the t observed. So then compare the observed value, that's the probability to get a t-value this large, compare that with alpha, and then to determine significance. So I'm going to scroll down here. So that's we call the p-value approach to determine statistical significance. So the steps 1 to 4 remain the same. I'm going to state that now. In alternative significance level, identify that test. Those remain the same. And we also, so we're not going to calculate critical value using this approach. So this, instead we're going just to go directly to calculate the test statistic. So which we calculate here is a 1.68. So step next is we want to find in the t distribution here. So how likely to find 1.68 this large either side, because this is non-directional test, two-tailed test. So we're going to find how likely to find a t-value this large, 1.68. So either side. You can see that it should be larger than 5%. So use our table, we can kind of estimate the likelihood to find t-value this large. So looking at degree freedom 22, you can see that the t-value, so this is a 1.74. Beyond this t-value, this is more than 10%. Like here, 2.07, that's our critical value. Beyond this t-value, there's a 5%. So that's only 5% chance that we observe the difference. So now we have this 1.68, which is a little less than 1.714. And that tells us that probability of finding t-value 1.68 or larger should be more between these two values, should be more than 10%. Okay, we can calculate the p-value using the formula. So this is using t distribution and the function, and then we all put the this is the x is the t value. Yeah, so 1.68. Degree freedom is 22. We're looking at the two-tailed. So this is the probability we get for this. Yeah, let me just going to round it off. So this is the observed p-value. Remove this above. So I get, yeah. So the probability of getting t-value in this large is 11%, about 11%. And so we compare this is called observed probability level with the criterion level, which is the alpha level. So since the probability is larger than 5%, so we're also going to fail to reject, because the less the p-value, the more evidence against none. Yeah. So either approach, yeah, so we'll get the same conclusion. And that's the end of this tutorial. Thanks for watching.